We've looked at the properties of quadrilaterals, but now we're going to look at the diagonals of these same quadrilaterals. They have some specific properties as well. Now, remember that a diagonal is going to go from one vertex to the opposite vertex in in a diagonal fashion. So it's not going to be one that would overlap a side, basically. So it's going to go in the middle of the shape. So let's look at these. So remember a parallelogram. We have two parallel sides, two pairs of parallel sides. And so our diagonal here is going to go across and across here. So what you need to know about these diagonals is that they are going to bisect each other. So whenever I talk about bisect, remember that means it's going to cut the other segment in exactly in equal parts, exactly the same part. So basically what we have a segment here. This is going to be equal to this piece here. It's bisected by the longer segment, the longer diagonal, and then this piece will be equal to that piece as well. So that's for a parallelogram. Now for a rectangle, so for our rectangle here, we are going to, remember we have the diagonals are actually going to be congruent. Now, if you'll remember back to Pythagorean theorem, a lot of times we had to find that diagonal length, and it didn't matter which diagonal you chose because they were the same, and so therefore kind of falls into place here. So the diagonals are congruent for a rectangle here. Now let's look at a square. So just like with a rectangle, these are going to be congruent as well as bisecting. So just like with the parallelogram, so you take a parallelogram and the rectangle, and those two pieces are going together. So this piece is equal to this piece, and this piece is equal to that piece, which they're all going to be the same. So if you had a square piece of paper and you folded it in a diagonal fashion, those two lines are going to be the exact same, whether you fold it one way or the other, and each piece will all be the same. So really, we would have something like this. So all the diagonals are going to meet together. So diagonals are congruent and they bisect each other. All right, let's look at a rhombus. So if you remember, a rhombus is what I would consider like a square parallelogram where you have all the sides are the same. And so our diagonal here, they are going to as well bisect each other, which means that this piece is equal to this piece and this piece is equal to this piece. So the diagonals are bisectors, as well as being perpendicular to each other. So the diagonals are perpendicular bisectors. That's what we would kind of put those together. So they're going to create a 90-degree angle everywhere. Okay, all those are going to be 90-degree angles. Perpendicular, remember, means that they're going to make a 90-degree angle. So they're perpendicular bisectors. And they're going to cut this angle into equal pieces. So this angle gets cut into equal pieces as well. So they are angle bisectors as well. All right, now then let's look at a kite. So for a kite, remember you have two pieces that are the same, that are congruent, and then two more pieces that are congruent to each other, but the other two are not the same here. So with the diagonals here, so you have a diagonal across and here. So it looks almost just like a kite, right? So they are going to be perpendicular. So they are perpendicular. So they're going to create a 90-degree angle all around there, okay? And then also this piece is going to, or the longer one, what they call the main diagonal, is going to cut the shorter diagonal into equal pieces. So it's a bisector there. So they call that the main diagonal. And remember that that bisect means it's in equal pieces. Now, they intersect. Okay, the other one, the shorter one, intersects the main one, but it doesn't cut it into equal pieces there. All right, and then the last thing we're going to look at is a trapezoid. So our trapezoid, and we're just going to look at isosceles trapezoids. So this piece has to be equal to this piece, and for an isosceles trapezoid, and therefore our diagonals are congruent. For isosceles only, okay? So any other trapezoid, that's not going to be the case. It has to tell you that it's an isosceles trapezoid, and it has to tell you that the two non-parallel sides are congruent. Okay, so now let's take a look at some of these examples here. So the diagonals of kite ABCD is shown below. If two diagonals intersect at point M, so they're intersecting here at point M, and the length of DB is 36. So all the way from here to here is 36. What is DM? So remember that the main diagonal, the longer one, so AC is the main diagonal, that's going to cut the other one in exactly half. So basically I can just take 36 and divide it by 2 and I get 18. That would be the length of DM. All right, so it's just half of that would be just the piece. All right, the next one you'll notice we don't have a picture here, so we're gonna have to draw it. One diagonal of a rectangle has a length of 8x plus 2. The other one has a length of 5x plus 11. Find the length of each diagonal. Well, and it says each diagonal. Well, guess what? If we find the length of one of them, that's going to be equal to the other one. So remember that the diagonals of rectangles are congruent. So I'm just going to draw this little rectangle here. So I know that this diagonal is equal to this diagonal. So I'm going to call this, I'm just going to start labeling this. You don't have to do this if you don't want to, but I know that DB has to be equal to AC, which is 8x plus 2, and then you can flip-flop these because it doesn't tell you specifically, but they're still going to be equal. And now I'm going to solve for x, so subtract 5x on each side. So 3x plus 2 equals 11. Subtract 2, and 3x equals 9. Lastly, dividing by 3, x is equal to 3. Now, that's not what it asked for. It asked for the length of each diagonal. So I need to go back and plug it in to one of them. It doesn't matter which one. So I'm going to do 5 because I like multiplying by 5. It's easier. So 5 times 3 plus 11, that's going to be 15 plus 11. That's going to give me 26. That's my answer. Okay, so stop there. Don't stop at just the value of x here. If you had plugged it into the other equation, guess what? 8 times 3 is 24 plus 2 is 26. Doesn't matter, still the same thing. Okay, let's look at example 3 here. So trapezoid TUVW is shown. The length of TV is 2x plus 5, and WU is 6x minus 23. So what's the length of TV? So what we're going to do, remember that this is an isosceles trapezoid. It doesn't tell us in the problem, but it does tell us because they have marked these two sides to be congruent. The non-parallel sides are congruent here. So I'm going to say, so if I have TV, that's going to be 2x plus 5, and WU, this is a little bit nicer because they are written for us. So 6x minus 23 is going to be equal to 2x plus 5. I'll subtract 2x from each side. And so 4x minus 23 is equal to 5. Add 23 to both sides. 4x is equal to 28. divide by 4, and x is equal to 7. Now, it didn't ask me for the value of x. It asked me for the length of TV, so I need to go back and plug that in for TV. So I have 2, so TV is going to be equal to 2 times 7 plus 5. This makes 14 plus 5, which is going to be 19. So the length of TV is going to be 19. And then looking at the last one for the parallelogram below, QN is 42 and QT is 2x plus 9. And then MT is 5y plus 3 and TP is 2y plus 12. Find the values of x and y. So remember, for parallelograms, the diagonals are going to bisect each other. Bisect means it's going to cut it in equal parts, and basically in half. So we're going to have QN, so this whole piece is 42, and we know that part of it is 2x plus 9. Well, I can either have 2x plus 9 plus 2x plus 9, since I know that those two pieces are equal, or I can cut 42 in half. I can cut 42 in half and make that just this little piece here. So if I cut 42 in half, that's going to be equal to 21. So then I would have 2x plus 9 is equal to 21. And then just solve from here. I'm going to subtract 9, and so 2x is equal to 12. Divide by 2, and x is equal to 6. That's part of it. So either way you decide to do, it doesn't matter because it's a bisector, okay? On the other one, we have MT, which is 5y plus 3, and then TP is 2y plus 12. So 5y plus 3, and then 2y plus 12. This time I don't have the whole length, so I can't cut anything in half, but I do know that this part, MT, has to be equal to TP, and so I can set those equal to each other. So 5y plus 3 has to be equal to 2y plus 12. And then I'm going to subtract 2y from each side. That gives me 3y plus 3 equals 12. Subtract 3 from each side, and I get 9. 3y is equal to 9. Divide by 3, and y is equal to 3. All right. So a lot of work there, but just kind of keeping those properties, like what properties go with just the regular quadrilaterals and what properties go with the diagonals now. So we're kind of throwing in some more with you there. A lot of them you can kind of sort of just deduce down to, and just remember, some of them, like the diagonals of a rectangle are equal because we did Pythagorean theorem and it didn't matter which way you went. So some of those things will help you with your skill check as you start practicing.